Ever seen a UFO? However implausible they may be, the idea holds a powerful grip on our collective imagination. And UFOs raise fascinating questions, not just about what particular sightings might be, but also about the nature of space travel and communication across the universe.
Answering those questions involves some incredible science. And so this month we ask, what have UFOs ever done for us?
Since I was a little girl, I always hoped that one day I would wake up to find visitors from another world. Sadly, I'm still waiting.
I wish we could bring you the first interview with aliens, but instead, we're back here at the Jodrell Bank Observatory, a place long associated with the search for extraterrestrial intelligence, and somewhere which is famous for studying objects so strange that they were labelled as little green men.
But this month is also a poignant reminder of how difficult space travel is. 11 years after it disappeared, the Beagle 2 spacecraft has been found on the surface of Mars. We celebrate a mission that came tantalisingly close to triumph.
Coming up, Dallas Campbell opens the MOD's UFO files and asks what it would take for aliens to visit us.
There are some basic questions we have to ask, and one of those questions is interstellar travel possible?
Pete reveals what really lies behind some of the most common UFO sightings.
Plus, the unexpected radio signal that for a brief moment looked like it might just be communications from little green men.
It was pulsing, which is not what a radio astronomer expects from the sky.
The three little letters UFO conjures up all sorts of images in our minds and have led to countless controversies.
Of course, when we talk about UFOs, we're talking about the idea of visitors from outer space. Although science doesn't preclude the existence of life elsewhere in the universe, scientists are extremely dubious about UFOs visiting us here on Earth.
Despite this, sightings keep coming in thick and fast. We've asked Dallas Campbell to investigate what people are seeing and to find out why the probability of aliens visiting our planet is so unlikely.
The modern UFO phenomena began in 1947. An American pilot, Kenneth Arnold, was flying above the Cascade Mountains in Washington state, where he described seeing 9 saucer-like objects flying as if they were being skimmed across the water. Since then, thousands of UFO sightings have been reported. Bright lights, mysterious dark shapes, and even the odd abduction. At the National Archives in South London, a wealth of these documented sightings are safely stored away. These are really exciting. These are the official X-Files documents, if you like. These are the MOD collated reports of unidentified flying objects. There's a great story of a whole load of school children who had seen an unidentified flying object and had written in to the Ministry of Defence, and all their letters are still here, and some of the children, in fact, had actually drawn pictures of what they'd seen. There's a letter here from the MOD, dated 1967, telling the children there were in fact low-flying aircraft in the area at the time. It sounds pretty plausible to me. This flying saucer report actually made the papers. This is from 1966. This amazing picture of a flying saucer filmed from an aircraft by a woman will set the world talking, and it certainly did. But luckily, good old Tomorrow's World solved the mystery.
Our cameraman sat in the same seat as Mrs. Oldfield had. Through the window, notice how the glass is slightly convex where it meets the frame. Here it comes, Tomorrow's World's very own UFO. What we are seeing now is in fact a direct view of the tailplane of the aircraft, seen at an acute angle to the window glass.
Whether these UFO reports are explainable or not, it's worth thinking about the UFO question from a different angle. If a civilization was visiting the Earth from a faraway solar system, there are some basic questions we have to ask. And one of those questions is interstellar travel possible? We live in a world governed by the laws of physics, and to the best of our knowledge, they apply throughout the universe. It's these laws that make interstellar travel so incredibly improbable. Of course, the problem with travelling around space is that space is big, really big, and the distance between the stars is absolutely vast. It's so vast that even light, which is the fastest thing we know, takes years to travel between them. Even our fastest spacecraft, like Voyager 1, would take at least 70,000 years just to reach our nearest star. So how could we or any other spacefarers cross such unimaginable distances? Well, you could try going really, really fast. But going faster is incredibly difficult, and not just for the obvious reason that it takes a great deal of effort. Over a century ago, Einstein worked out that the faster you travel, the heavier you get. If I were to accelerate up to the speed of light, then my mass would become infinite, and the amount of energy I'd need to move would also be infinite, which might get a bit tiring. But funnily enough, going fast is only part of the problem. Once you get to where you're going, how do you then stop? The faster you've been travelling, the harder it is to lose all that momentum you've built up. So in order to stop in space, you would need another engine with the same force pushing you back the other way. And this is a problem we struggle with in our own solar system when we send probes to other planets. Stopping a spacecraft once it's reached its destination is one of the hardest things in space exploration. There may be a way around this though. Instead of trying to go faster, could we not make the distance itself shorter? Crazy as that sounds, there may be a way to do just that. There's a theoretical solution to this interstellar dilemma, something known as a wormhole. These are tunnels through space-time connecting two distant places. Cosmic shortcuts like this could hold the key to visiting other worlds. I'm meeting theoretical astrophysicist Roberto Trotta to find out how likely these sci-fi staples really are. Theoretically, is it something we can even consider, or even think about, even talk about?
Conceivable, yes, absolutely. And theoretically, you can find solutions to Einstein's general relativity equations that describe such a shortcut, a wormhole, in fact. But you want to be able to go through it and possibly come back.
In theory, a wormhole could be formed by two black holes connecting to create a bridge. But there's a problem.
This possibility wouldn't be traversable. You wouldn't be able to take a shortcut through a black hole.
No.
Because, well, first of all, practically, you'd be dead.
It would probably hurt.
It would hurt. Spaghettification terribly hurts.
What do you call it?
Spaghettification.
Spaghettification, okay.
When you get spaghettified by
Yeah.
the tidal forces of gravity.
Okay.
And that's something you don't want to do, right? So in terms of if you instead want to engineer the wormhole of the kind that would allow you safe travel, you might possibly be able to use one that's already there, but even that is not guaranteed because a wormhole will need to have a large amount of negative energy, which is something we don't really know if it exists.
But let me get this clear. We don't know if there's any wormholes. We haven't made one, or this is all
speculative. It's all theoretical. It's all equations on a board, effectively. People speculating about what kind of reality those equations could possibly describe.
Got it. No one said, "Oh, look, what's that funny thing? Oh, it's a wormhole." We're not even.
No, we don't.
Okay.
We don't even know how to look for one.
So let's just assume a wormhole had happened. Presumably, we're going to run into all kinds of practical problems still. It's not just easy, we built a wormhole, we can all go on holiday.
There is the strength of the forces, the time it would take, not to you as the traveler, but the time that would pass for people back home. Time would flow differently for you than for people back home. And so you don't want to go on holiday and then come back and everybody has died 10,000 years ago. That would be silly. And the other problem is that even just theoretically, if such wormholes were to exist, you could use them to travel back in time, effectively, which seems to be something that's fundamentally forbidden, and that might be an argument why they might not exist.
Yeah. South of France is nice this time of year. I think I might just plumb for that instead.
Yes.
Even though the probability of finding aliens that have zipped across the universe to visit us is very small, there's still a possibility that they're out there. As a result, we've combed the cosmos, searching for signs of their existence. Chris is speaking to pioneering astrophysicist Jocelyn Bell Burnell, who discovered a signal that looked like the one we'd been waiting for.
It had long been assumed that if an alien civilization tried to make contact with us, the signal they send would have some key characteristics. It would be in the radio part of the spectrum, as radio waves travel easily across the vastness of interstellar space. It would be persistent, not a one-off, and it would have a rapidly repeating pattern. This is exactly what was found in 1967.
Jocelyn, we have to start by talking about this remarkable discovery that you made in Cambridge in the late 1960s. So what were radio telescopes like then? What were you using?
Radio astronomy, at that stage we quite often built our own radio telescopes. 4.5 acres, lots and lots of wooden posts, looks a bit like a hop field, wires trailing along the top of the posts. 120 miles of wire and cable in that radio telescope. But it worked.
And the output was primitive too?
Yes, everything came out as hard copy. Moving pen over chart paper. Wiggle, 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 wiggle. 100 feet of chart paper every day.
And in inspecting that vast amount of paper, you spotted something unusual. What flagged this particular signal as an interesting discovery?
Well, it didn't look exactly like the quasars which I was meant to be looking at. It didn't look exactly like interference. It turned out to be a thing that was pulsing once every 1 1/3 seconds, which is not what a radio astronomer expects from the sky. It's regular and it's rapid. Stars can't turn on a sixpence. This thing was. What on earth is it? It's all the hallmarks of artificial, man-made interference, but it's coming from the same spot amongst the stars.
And so it got this nickname, LGM-1 for Little Green Men. Was that a serious consideration at the time?
I named it, and I have to say I now regret it. It wasn't serious, it was very much tongue-in-cheek. And we did check out whether it might be little green men, extraterrestrial civilizations, arguing that if it is, those little green men live on a planet that goes round their sun. And as the planet goes round their sun, some of the time it's coming towards you, the observer, and the pulses pile up closer, and sometimes it's moving away from you, and the pulses spread out. So I did a lot of careful monitoring of pulse arrival times, and we found one of these Doppler shifts, as it's called, but it was due to the motion of the Earth round the sun, because Doppler shift works for the Earth moving as well as the source of the radio waves moving.
And so you'd successfully discovered that the Earth goes around the sun.
We proved it, yes. Yep.
So you had one of these things.
Yeah.
What happened next?
It was about a month after we'd found the first one, and we had a meeting to discuss how to publish this. It's a real problem when you've got one example of a crazy result. And I remember that meeting because that night, looking at some chart recordings from a totally different bit of sky, saw a 1/4 inch of suspicious looking signal. Pulse, 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 pulse. This time 1 1/4 seconds apart. But clearly the same kind of thing, same family, totally different bit of the sky. And that was the eureka moment. The first one was just too darn worrying.
These things turned out to be what we now call pulsars.
Yep.
So what do we know about pulsars? What are they?
They're formed in supernova explosions. Part of that explosion is the collapse of the core. And a pulsar is a collapsed core, weighing about the same as the sun, but it's all squashed into a ball about 10 miles across. So really dense. My analogy for the density of a pulsar is you take a sewing thimble, you take the population of the globe, you jam the 7 billion people one by one.
Carefully.
Hard into this thimble, and when you got it full of 7 billion people squashed, it weighs the same as if it were made of pulsar material. So it's really dense stuff, and the whole thing spins incredibly fast. Some of these things are spinning 700 times a second, really fast, scarily fast.
And we see these as these very rapid pulsations.
Yes, and incredibly regularly, because when you get 1,000 million tons of stuff spinning, it's very hard to make it change its spin, so that it's a clock. And indeed we make use of that these days. These things are clocks out in the galaxy, and we use them to check out Einstein's relativity.
We should talk about another mystery, something that's been bothering radio astronomers recently, which are these things called fast radio bursts.
Yeah.
What do we know about them?
Not a lot. They've been picked up by the pulsar people because they're short, sharp pulses and pretty strong. And I think the first thought was, oh, this is a freakishly large pulse from a pulsar. But actually, nothing ever comes from that bit of space again. For one of them, they've had another 8 telescopes quickly slew to the position. X-ray telescopes, optical telescopes, more radio telescopes. There's nothing to be seen after the burst has happened. So there's a and that's it.
It's fun we're still finding these things.
Isn't it? And I think there'll be more as we do more of this short time duration, transient astronomy, which astronomers are really only getting into now. It's just beginning.
To find out more about fast radio bursts and how astronomers are trying to find them, check out our website at bbc.co.uk/skyatnight. In a few moments, we'll turn from aliens travelling to visit us to the problems we humans have exploring our own solar system, as we look at Britain's attempt to visit Mars with Beagle 2. But first, Pete Lawrence is here to show us how easy it is to find UFOs.
There are all sorts of things up in the sky which try and trick us into thinking that aliens are visiting from other worlds. And I want to show you what some of these things are. Our skies are populated with objects that at first glance look like they're straight out of a science fiction film. One of the most common are clouds. Some clouds look really otherworldly. Just look at this amazing image back here. Now, these are what are known as lenticular clouds, and this particular photograph was taken from Halifax in the UK. But typically, lenticular clouds form over mountainous regions where the weather is warm, moist, and stable. But there are even stranger clouds than this. This bizarre gap in the cloud is called a fall streak hole or hole punch cloud, and it occurs when something happens to cause ice crystals to form right in the center and fall out of the sky, leaving behind this amazing hole. Of course, some UFO sightings are actually space-based. Many people mistake satellites for either planes or shooting stars, but sometimes when the conditions are just right, they can look really spectacular. This is what's known as an iridium flare. What you're seeing is sunlight reflected off flat surfaces on the satellite's body. It's so UFO-like because the light appears from nowhere and then just vanishes away. The most unpredictable, and if you go onto our website, there's a link there to help you find out how to see a flare for yourself. But there are stranger appearances still. From time to time, rockets carrying spacecraft into orbit dump fuel, and this can create a bizarre and mysterious glowing shape which is visible in the night sky. And then there's this. This was taken from northern Norway in 2009, and it's not a manipulated image. This is actually what was seen in the sky. Hard to believe as it may be, this was the result of a Russian missile test. The rocket malfunctioned, leaking a trail of fuel as it spun. But the other factor was the time of day. For the photographer, the sun was below the horizon, but up in the upper atmosphere, the sunlight was able to illuminate the released fuel, creating this spooky effect. Finally, the celestial object that's most likely to be confused with a UFO has to be the planet Venus. Now, it might sound strange to think you could mistake a planet for a flying object, but Venus certainly seems to be able to pull off this trick. And there are apocryphal tales of pilots seeing Venus and thinking it's an oncoming aircraft.
And now to the news from Mars. Beagle 2, the UK's first and only attempt at a Mars lander, has been missing, presumed destroyed for over 11 years. But now, a team using images from NASA's remarkable Mars Reconnaissance Orbiter think they've seen signs of Beagle safe on the surface. We'll be finding out what this means for the mission in just a few moments. But first, let's remind ourselves of the Beagle story and what happened over Christmas in 2003. Beagle 2 was designed to sample the surface of Mars. The lander was the brainchild of Colin Pillinger, who believed passionately that Beagle could answer the big question, whether there was life on the red planet.
There is every chance that there could be a niche on Mars where there is some kind of life. That's what Beagle intends to do, analyse the atmosphere, see if there is a trace of methane in the atmosphere, because if there is, it shouldn't be there unless there's biology constantly producing it.
Beagle 2 was carried to Mars on board ESA's Mars Express, but strict weight restrictions and a firm deadline meant the tiny probe had to rely on a novel and untested landing system. It involved using a series of parachutes to slow the spacecraft in Mars's thin atmosphere, and then hoping that airbags could cushion its impact. The mission captured the public imagination. Cultural icons Blur recorded a call sign to be played when Beagle woke up, and Damien Hirst got involved, designing the colour calibration card. In late December 2003, Beagle 2 began its treacherous descent, with touchdown scheduled for early on Christmas Day. Colin and his team waited for the landing signal to come back, but none was received.
On this mission, our faith has been unshakable that the mission would go ahead, and we've crossed lots of bridges to get this far, so we'll keep the unshakable faith until the point comes when we have to say it's no longer worth thinking about.
Despite weeks of trying, contact was never established with the little spacecraft. The mission was branded a failure. ESA concluded that the landing system probably didn't work and that Beagle 2 had crashed into the surface. But Pillinger, the eternal optimist, didn't agree.
I never ever believed that we'd crashed, and I certainly probably don't now.
Sadly, Colin never lived to discover what happened to his spacecraft. He died in May last year. But now, we know. The latest images from Mars suggest that Beagle came closer to success than almost anyone had thought. And Maggie's talking to Jim Clement, who worked on the Beagle team.
It's 11 years since Beagle 2 disappeared. How come we've found it now?
The high-resolution camera on Mars Reconnaissance Orbiter has, over the years, been taking images of Mars, including about 11 or 12 overlapped across the landing ellipse of Beagle 2. And a number of those images are showing an artifact on the surface of Mars.
The images appear to show a number of objects that scientists believe were the rear cover, parachute, and the lander itself. Even though it's just a few pixels wide, closer views appear to reveal the telltale shape of Beagle 2 and suggest that the spacecraft had begun to deploy its solar panels.
So this is the first panel to come out, and this is covered about 80% with solar cells, which are glass.
So very reflective.
Very reflective. And then the next panel would be this one. And we think we're looking at something like that.
And if this is the case, it radically changes our view of the mission's success.
Well, it means that the entry, descent and landing system worked, that the lander survived impact onto the surface, that all the electronics absorbed that shock.
So Beagle 2 was not lost after all. Not only did it successfully touch down on Mars, it also began to operate. So why have we heard nothing for over a decade?
If we open these up now, you'll see. So underneath here is the antenna.
Aha, yes.
Okay, so if all the panels had had opened up as we see now, then the antenna would have been free to communicate, and then the mission would have been able to proceed. And so whilst we know where Beagle is now, there's no means of trying to restart it. There's no way of communicating.
Yes. Even so, Beagle 2 still has a hold on us.
There are other parts of the Beagle mission that were also a success. For example, encouraging young people into science, technology, engineering. And I know there are people out there now who are engineers or scientists because of Beagle.
Perhaps the late Colin Pillinger summed it up best.
It was not a failure. Deferred success. Triumph, not disaster.
Now, back to all things UFO. And if we're serious about finding aliens, we don't have to wait for them to come to us. We can look for them. Here at Jodrell Bank, they're working on a system that will allow them to use their radio telescopes not to look for flying saucers, but to search for signals from alien civilizations out in space. The question is, what would that signal look like? A regular pulse would be a good clue that the signal was artificial, but we now know that's how pulsars appear. And so the team at Jodrell are taking a different approach. They want to hunt for radio emission that's confined to such a narrow frequency range that they have to be artificial.
This is the live data coming in now off one of the telescopes. So what you're seeing basically is this is frequency in the radio spectrum.
So like tuning your radio at home.
You could tune to different frequencies along here.
So there are signals there.
Yep.
So that's it. Aliens.
So you could
We're done. People are communicating with us.
If it was easy as that, that would be great. So what you've got to do really is tell the difference between things that are natural sources of radio emission and artificial sources. So we'd assume that the aliens are producing some sort of artificial radio emission.
Natural sources of radio emission, like stars or planets, should emit across a broad range of frequencies. And that's what the Jodrell radio telescopes are used to picking up. But within this broad spectrum, there might just be a hidden signal. And so whilst the radio telescopes are scanning the sky looking for everyday phenomena, Tim is going to use the supercomputer here at Jodrell to scan data that's normally thrown away, hoping to find that telltale signal.
What you'd be looking for is a sort of spike rising and falling